Eureka, 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 Eureka!
I got it!
Welcome to Eureka Publication Private Limited, creators of engaging textbooks and digital learning tools. Let's dive right in.
Let's create electricity with a moving magnet and a coil of wire. We will build a simple generator and see how the galvanometer responds. We'll also connect this to Faraday's law and Lenz's law and finish with the motor effect to see how reversing current reverses force. Here is what we need: a solenoid, which is a coil of wire, a bar magnet with a north pole and a south pole, and a galvanometer, which detects small currents. First, connect the ends of the solenoid to the galvanometer to make a closed circuit. Here is our setup: a coil connected to a galvanometer and a bar magnet near the coil. We will push and pull the magnet to see the needle move. First, quickly push the north pole into the solenoid. Watch the galvanometer. The needle deflects to one side. When the magnet stops moving, the needle returns to zero. Now pull the magnet out quickly. The galvanometer needle flips the other way. When motion stops, it returns to zero. Now repeat with the south pole. We reverse the magnet, so the south pole faces the coil. Push in quickly. The needle deflects in the opposite direction compared to the north pole. Pull it out, and the needle reverses again. The key idea is that a current is induced only when there is motion, because the magnetic flux through the coil is changing. When flux increases or decreases, an electromotive force appears. Faraday's law says, script E equals negative d phi b by dt. The negative sign encodes Lenz's law. The induced current creates a magnetic field that opposes the change in flux. In this activity, the mechanical energy you use to move the magnet is converted into electrical energy in the wire. This is electromagnetic induction. Now, for the motor effect. A current-carrying conductor placed in a magnetic field feels a force. Here the magnetic field goes from the north pole to the south pole, left to right. The current is out of the screen, shown by a dot. The wire is pushed upward. If we reverse the current, so it goes into the screen, the force reverses direction and pushes the wire downward. To summarize, a changing magnetic field induces an electromotive force and therefore a current in a closed circuit. The direction follows Lenz's law, and the size depends on how fast the flux changes. Faraday's law says script E equals negative d phi b by dt. The motor effect is the reverse idea. A current in a magnetic field experiences a force, and reversing the current reverses the force direction. This is the basis of electric motors and generators.
This session was brought to you by Eureka Publication Private Limited. Think it, dream it, do it. Join us for the next lesson. Till then, like, subscribe, and share. Eureka Digital Publications, creators of trusted textbooks and digital learning tools.